This video is going to, it's made for JavaScript developers who want to participate and sort of kick the tires on this Bch Dex project. So this is a decentralized exchange for trading SLP tokens for BCH, Bitcoin Cash. So the project is an early prototype, and things are going to break. So this is really only for advanced JavaScript developers. And I put the date here. It's March 27th, 2022, because the code is undergoing rapid changes, so it's probably going to change drastically very quickly from this date. So if a significant amount of time has passed, much of this data might be outdated, so just keep that in mind. Again, this video is really just to wet people's whistle, to sort of give them a taste. If you are a JavaScript developer, you've been following me and the software that the Permissionless Software Foundation has been building, and you're really excited to get started, this video will help you do that. But also keep in mind that there's going to be a lot of frustration involved, so you're going to have to overcome that in order to really try out this software. But I hope that you do, and I hope that you become a contributor to our project. So I'll be following the instructions in the README for the software project, and this is the URL that you can follow to find the project, the code, and the README. And this QR code, you can scan that. It just has this link embedded in it. So here's the software project. It's on GitHub under the Permissionless Software Foundation GitHub group, under the repository Bch Dex. And and before I get too deep into this, I should point out that I already created an overview video, and I linked to it in the Telegram channel, and it's also on my YouTube video here, and I will link to it in the README as well. That is just a very high-level overview, so you should definitely watch that first before you dive into this video. So I'm going to assume that you've watched that video, and now you want to try to install it and play around with it and experiment with selling tokens on it. And so if you have any questions as you watch this video and follow these instructions, I have links to our Telegram and our Gitter channels. You can go there. And largely I'm just going to walk through these instructions here in this video, but I wanted to create a video because there's a lot of nuance that is lost with just simply written text. So if you read this README and watch this video, between the two you should have a pretty good chance at getting it up and running. So but before I dive into that, let me give some disclaimers. Everything is buggy right now. This is a brand new project. It's just barely functional. The whole purpose of creating this video is to entice other developers to help me improve the software and make it better. And so as you play, so only use small amounts of money, and that's a great thing about Bitcoin Cash. It's easy to just trade 1 or 2 cents at a time. And the transaction fees are low, and the dollar numbers are low, and we can do all this on mainnet. So do not trade large amounts of tokens. That's absolutely irresponsible to be doing that right now at this point in time. This is not a production-ready thing. It's very far from that. So if you lose any money, you are the only one to blame. If you create a ridiculous offer for a bunch of tokens and someone takes the other side of the offer and takes your money, there's no way anybody can get that back for you or reverse it. So big caution tape across all of this stuff. You are totally responsible for your money, and if you lose it, that's on you, and no one can help you. So just accept that moving forward. Another reason that you want to follow this software is that you have to be online to accept trades. So there's 3 parts to a trade. There's the making of the offer, there's the taking of the offer, and then the third step is the acceptance. And if your node is not online to accept it, then the trade won't be completed. And so I'm going to talk a little bit about the Raspberry Pi and why that's a great target for this software, because it can be an appliance. It can just sit in the corner and run and be connected, and any trades that you put up, it'll automatically accept them and complete those trades for you. So this video is going to have 4 parts, and so if you are trying, and this is going to be a very long video, so I will try to display this slide in between the 4 different parts. So if you want to fast forward, just look for this white slide, and that'll help you sort of orientate where in the video it is. So yeah, feel free to fast forward to these different sections as needed. And I'm also going to go fast because it's a video and you can pause it. And I'm going to skip, the video when I'm installing packages because that takes time and it's not very full of information. So, okay, so let's start with where to find information on setting up the environment. I'll jump into the README here. This is all called out in the README. So we've got the different chat channels to go to if you need help. I guess I'll get down to here. I want to call out the PSF video, but first I'll just go down this in order. So the Dex is actually, what is this? 1, 2, 3, 4, 5 different pieces of software all operating together to create the Dex. So the Bch Dex is actually the back-end software. So the server side, what would traditionally be called server side, but that doesn't really apply here in P2P software. You run everything on the same computer. So this back-end software, it tracks offers and it generates counter offers and it accepts counter offers. So that's basically what the Bch Dex software does. And then there's Bch Dex Ui, which is a Gatsby web app, and I can show it here. This is what you'll pull up to actually accept trades. So it's a user interface, a graphical user interface in the web browser, but as you can see here, I'm serving it locally on port 4500. So these are all different Docker containers that you're going to spin up. And so there's the pay-to-write database. So this is a PSF project. It's a censorship-resistant database. It's similar to a blockchain, but it's more of a database than a blockchain. It's censorship resistant like a blockchain, but you can store a lot more data in it than you can on the blockchain. And so this is really the core database that keeps the exchange censorship resistant and ensures that no state actor can prevent this software from running. And that is in turn built on top of IPFS, the Interplanetary File System, which is a censorship-resistant network for communicating data over the internet. And then there is a Mongo database container, and that's used by both the pay-to-write database and the Bch Dex to store and manage data locally. So again, these are all 5 different Docker containers that you're going to spin up, and you're going to orchestrate them with Docker Compose. So we're targeting 2 hardware targets and 1 single operating system. So Ubuntu 20 is the operating system, so that runs on both a normal desktop PC or x86 hardware or AMD 64, as well as a Raspberry Pi 4, which is this ARM 64 architecture. So if you're on Windows or you're on iOS, I recommend you buy a Raspberry Pi 4 or a Pi 400. I'll talk about that more in a minute. That way you can just run the software on the target hardware and you won't have any problems. If you try to run it on those operating systems and you run into problems, maybe you can get help. I certainly won't help you. Those they're not under consideration. We don't care if they don't run on those operating systems properly. Again, this is a perfect piece of software to run on a Raspberry Pi 4 because of the appliance factor. It's basically an appliance that can sit in the corner and do a job for you, and the best operating system for that is Linux. So this gist is something I put together, and actually let me pull up the video page because that'll give it even more context. So one thing that you should definitely probably pause the video and spend some time exploring is the Permissionless Software Foundation's website, and in particular this video page, which you can get to in the menu here, or just follow the link in the README. But I'm assuming you're not a brand new beginner, but if you've never used Bitcoin Cash and need help figuring out how to work with a wallet, there's this section. I definitely recommend checking out the videos in this beginner JavaScript. In this video, I talk about the Pi 400 or the Raspberry Pi 4 and why it's our target hardware reference. The idea is to get this decentralized software running everywhere in the world So we try and use ubiquitous operating systems, ubiquitous software, and ubiquitous hardware. And the Raspberry Pi is ubiquitous. It's $100. You can buy it anywhere in the world, and it runs the software. And we show you in this video how to install Ubuntu Linux on it, and then how to set up screen sharing, which I'm going to be using today, and how to set up PiClone, which is a handy software for cloning the SD card on a Raspberry Pi. So I definitely recommend checking those out. Also, if you don't have access to a Raspberry Pi, you can use a normal desktop PC. That's our other target hardware reference, is a $400 desktop with a 1 terabyte hard drive and 32 gigabytes of RAM running Ubuntu 20. This can actually run our entire stack of software, whereas the Raspberry Pi just runs basically the consumer software. And I won't go too into depth there, but one of the videos I want to call out is setting up a new server. In this video, I talk about this gist, which shows how to set up all the sort of basic development environment for either the Raspberry Pi or the desktop. And in particular, I show how to install Node.js. I recommend changing this to a 6 to install Node.js 16, but either one will work. How to install Docker, how to install Docker Compose on an AMD 64 or desktop PC, and how to install Docker Compose on a Raspberry Pi. These software are essential, Node and Docker Compose. You're going to need to install these first before you move on to install to the rest of these instructions to actually set up the software. You have to have those software installed first. So that's actually the first instruction on setting this up, is follow the gist to install Node.js and Docker Compose. And what I've got here is my Raspberry Pi running remote desktop right here if I need to actually do anything in the graphical user interface. But primarily I'm just going to be using the shell. And so I've got that here. I'm logged in remotely to my Raspberry Pi. And I've actually got the system running here on my x86 PC, and so I'll use this to sort of interact with it once we've got it set up. I've got the Pi running on a USB stick that's 256 gigabytes or something like that. So I've got lots of space. So I recommend doing something similar, because this is going to take at least 16 gigabytes, maybe more. You should have plenty of room. Like, you should probably have no less than a 32 gigabyte card in your Raspberry Pi in order to install this software. And more is always better. So I'm logged in here with into the Raspberry Pi. So let's see where we're at. Okay, so that's where to find the info for setting up your environment. So now I'm going to move on to setting up the Docker containers. And that's basically following the README here. So we've already talked about step 1. Step 2 is install dependencies. So actually, there is another step where I git clone. Let's see, so I've got a work directory. So I like to have a work directory. So I'm going to git clone this Bch Dex repository. That should actually be step 2. And then I'm going to go into that directory and I'm going to install the dependencies. Now I'm running node 16 and npm 855, so I'm going to install dependencies by running npm install. So that's this step right here. And I'm going to pause until this is complete. It'll take a minute. Okay, the npm dependencies are installed. So now we can create a wallet by going into the production scripts folder. Yeah, so this link will take you there. And run node create wallet. we go. Had a little hiccup with the internet connection. Node create wallet. This will create a new Bitcoin Cash wallet. So the app itself manages its own wallet, so the software is inherently custodial. In that this wouldn't manage multiple people's money; it just manages your money. So this is a brand new wallet that I created, and it will generate this wallet.json file. And so we're going to move the wallet to the RPi Docker directory. So if I go up and go into this RPi Docker directory and go into Bch Dex, I am going to move that wallet right here. Okay, so there's that wallet. And yeah, we'll just do that for now. Okay, so we created the wallet file, and we're going to go back into that production RPi Docker. So I'm in the RPi Docker directory because that's the target I'm building. There's also this Docker directory. So if you're on an x86 machine, you'll go into that directory. But really, it's just the directory that matters for the different architecture. Everything else is the same. And we're going to build these Docker containers with this command, docker compose build no cache. Now actually, what the no cache instruction does is it tells Docker to ignore any previously saved containers and build it from scratch. And if there's a software update out on GitHub, Docker won't automatically detect that. And so that's why you need to frequently pass the no cache flag, is to tell it, like, I know everything looks the same to you, but I still want you to go out to GitHub and retrieve, the repository, a fresh copy of it. That's essentially why the no cache flag is needed. So occasionally, if you know that that's not what you need, you can get around it, but for the sake of consistency, I'm going to try and use this no cache on every time, even though it takes a little extra time. So I'm going to give that a minute to build the Docker containers. Okay, that took a minute or two, a couple hours actually. The Raspberry Pi is pretty slow, but it'll get there. And so where are we at? Docker compose build with no cache. And now we're going to bring them up, and we're going to wait for the containers to run for about a minute, and then bring them back down with docker compose down. And that will create the folders in production/data. So if I go up a directory, there's no data directory. So a data directory will appear when we do that. So docker compose up D. And the first time you do this, as I'm doing it now, it will download the images, the MongoDB image and the IPFS image. And so that might take a minute if you're on a slow connection like I am. But it'll only do this once, just the first time you run it. Okay, so after it finishes pulling the images that first time you run, it will spin up the different Docker containers. So there's all 5 of them. And now if I go docker ps, I can see that they're all up. And now that they've had a few seconds to be up, I'm going to bring them back down, just like it says in the directions. So while those are spinning down, yeah, run for a minute, a few seconds, doesn't really matter. Just bring them down, because right now the IPFS network is running on a private network on IPFS, a private IPFS network. And so we need to copy the swarm key. We'll probably run on the main net at some point in the future, but right now this just eliminates a whole bunch of problems that we don't need right now. So while we focus on making the software we have built better. So if I go up a directory, there's now this data directory there. And if I go in there, I'll take a minute to explore this and explain this. There's 3 directories. So database holds the MongoDB database. Go IPFS holds the IPFS data. So there's a data, I'm not sure what the export is, but blocks is the directory where the data gets held that IPFS downloads, which doesn't do very much. And config is if you wanted to configure this IPFS node, that's the file that you would edit. Like if you run multiple instances of IPFS on the same machine, you would have to edit that file. And then finally this IPFS data, this holds the pay to write database data. Okay, so in the main directory there is this swarm key, and so we want to copy that to production rpy docker, into data. Go IPFS data. There we go. And I'm just going to go in there and show what that looks like. Okay, I'm in the IPFS data directory. There's the swarm key. So now it has what it needs to join our private network. So I'll go back into the rpy docker directory. And I'm going to bring it back up and wait for the pay to write database to sync. So I visualize the software as a stack. I realize if you're seeing this for the first time, it probably looks like a jumble. But IPFS is at the bottom of our stack, and then the pay to write database sits on top of it, and then Bch Dex sits on top of that, and then Dex Ui sits on top of that. So if we go docker logs follow IPFS, I just want to make sure that we're starting up. It looks good. Daemon's ready. This means it's on the private network. We're running version 11 on the rpy. Couldn't find an image for version 12. Okay, and then I want to take a look at Bch Dex. And that's looking pretty good. Actually, first I want to look at the pay to write database. And what I'm looking for are these right here. This is data coming in. So the pay to write database is like a blockchain in that your node is downloading the data from all the other nodes on the network and verifying each entry to make sure that it paid to write to the database. And I won't get into that. The pay to write database is a subject all on its own. Actually, I'll just bring this back up. So if it's been running for a while, so F is follow, and then --tail 20 means start by only showing me the last 20 lines. That way you don't have to scroll through everything that's ever existed. But it's these sort of JSON things that information that we're waiting for that, basically give it an hour or give it a half hour to sync. And what this is doing is it's like I said, it's downloading the data, and then if we look at the Bch Dex, we can see that the pay to write database is calling this pay to write database. So there's a webhook in between the pay to write database and the Bch Dex. So as people put information on the pay to write database with a specific sort of call out that it's for the Bch Dex, it'll trigger a webhook, and the pay to write database will pass that data on to the Bch Dex. And this is how Bch Dex detects new offers and counter offers coming in from the network. And so at this point, just leave it for a half hour and let it sync. And then we'll move on to actually trading. The system will then be ready at that point, and we can start trading. So what I'm going to do, is monitor the pay-to-write database for these JSON blobs to slow down or go away, and I'll know that that'll be a clue to me that in this little message is valid signature true. This is it checking the signature and the the transaction data, and so that's the information that should go away. This information here, pub sub, this is just IPFS information, and that won't go away. That's pretty normal. That'll stick around, and these sort of errors connecting to peer, that's just IPFS information for debugging. It's those JSON printouts that will slow down. So I'm just going to wait and let this sync. Okay, I let the computer sit for a while, and those JSON strings stopped coming through. Like I said, I'm still seeing these status updates. I'll probably make this less noisy, so this probably won't be, you probably won't see all this noise in the future. But I'm pretty sure the pay-to-write database is fully synced. And so we are complete. This part of setting up the Docker containers is complete. Everything's running. And now I'm going to show how to use the user interface to buy and sell tokens, or what exists at this moment, which is a pretty rough prototype. There's actually no user interface for creating offers. There's only the UI for taking offers, but there's a pretty simple script to run. So I am going to bring Ramina back up. And connect to the remote desktop of the Raspberry Pi. Okay, and I'm going to open up Firefox. So this is the same thing as if you were sitting in front of the screen. So just letting Firefox come up, and I'm going to navigate to 127.0.0.1 port 4500. 4500. And it won't show anything at first. It's always a good idea to open the web developer tools. So this is Firefox, so I did that pretty fast. Hamburger menu, more tools, web developer. This will tell you what's going on. The network tab and the console tab, I usually drag those over here. This will tell you what's going on. So BCH wallet is not initialized, can't calculate the price of BCH. So what we need to do is create a wallet. If you go to the wallet tab, you can see this is just like wallet.fullstack.cache. There's no wallet here. And so what I'm going to do is go get out of those pay-to-write database logs. All right. And that wallet that we generated, I'm going to pull that up, and I'm going to copy this 12-word mnemonic in here and paste it. See if this works with remote desktop. Yeah, it did. Paste it in here into the import wallet card. And so this will mirror the wallet. So there's two copies of the wallet now. There's the one that Bch Dex, the back end, is using, and there's the wallet that the front end is using. And so they're the same wallet. So if I do one to one, I'll do one to the other, like spend a token or receive a token or Bitcoin Cash. So now that that is created, that's like a one-time deal. And now when I bring this up and I go to the orders tab, it'll show me all the orders that are in the system, and so they're on the network. And so currently there's 2. And so I could take the other side of these, except I can't because I don't have any Bitcoin Cash. So I'm going to send some Bitcoin Cash to this app here. And this is what's nice is it's the same wallet, so you can manage the app wallet now, visually, which is a lot easier for most people. So this will take me a minute. So actually, I was going to scan this QR with my phone and send it some BCH that way, but I decided instead I'm going to copy this address and open up my web wallet in wallet.fullstack.cache and send $1. No, I'll send 25 cents in BCH. And then I'm also going to send a PSF token, one single PSF token. The cost to write, so in order to, so if I refresh this now, the way you post offers and counter offers is to the pay-to-write database. And in order to write to the pay-to-write database, you have to pay 0.01 PSF tokens. That's the current rate. And so this app will not be able to make offers or counter offers if it doesn't have any PSF tokens to pay for the transaction. So I'm going to send myself some PSF tokens. So I just looked, there's no tokens in this wallet. So I'm back at wallet.fullstack.cache on my main desktop, and I'm going to send it some PSF token, one single PSF token. Now, in order to get some PSF tokens, you can go to psfoundation.cache and scroll down and follow the instructions to order them there. You can also go to our Telegram channel, which is let's see, if you go to psfoundation.cache, you can scroll all the way to the bottom, and there's a link to our Telegram channel, and I can tip you, or someone there can tip you PSF tokens if you ask nicely. And also in the PSF Dex Dev channel, which is dedicated to this project, you can go in there and I or someone else can tip you some like a PSF token just to test this thing out. Okay, so where was I at? I was going to send a token, and it looks like I did. And so now I'm looking at the Raspberry Pi desktop. I'm going to refresh, and there should be a PSF token there. So I have some Bitcoin Cash and I have some PSF tokens. So now I'm ready to list tokens, and I'm ready to purchase tokens. Just giving this a minute. There we go. Okay, one PSF token. Okay, so now this thing's ready to go. I'm going to go back to the orders menu. There's these trout tokens. I'm going to take the other side of this transaction for one trout token. And so I want to show what this looks like in the Bch Dex, because there's not a lot to see in the web browser. Okay, so here's Bch Dex. These are the REST API calls from the user interface. This calls it every, I think, 20 or 30 seconds to refresh the orders. And yeah, I'll just clear this out. Let's see. So I'm going to hit this take button and see what happens. So it's taking the other side of the trade. If I go back, I can see that this offer, which one was it? Offer take was called, and what it's doing is it's generating a counter offer, and then it's going to write that counter offer to the pay-to-write database, and the instance of Bch Dex that I have running on my local desktop, that's the one managing that's the maker of the order. So it will receive a webhook from the PayToWrite database and check it, and then accept the other side, like finalize the trade by signing it and broadcasting it. So what it's doing, it generated a new key pair. It's created the offer. This is the partially signed transaction. This is just the web interface, checking stuff. Garbage collector. Okay, here's the partially signed transaction. That's a debug step. And I believe right now it's getting ready to write it to the PayToWrite database. Once that's complete, so it's burning 0.01 PSF tokens, and it'll display the transaction ID for that transaction, and then that transaction is the ticket for writing to the PayToWrite database. There we go, proof of burn. So I could look at that in a block explorer, and it's going to be a transaction for 0.01. Well, it burned 0.01 tokens, so it's proof of burn. And so it will submit that with the data to the PayToWrite database as basically a proof of receipt. And, okay. And so that got submitted. I'm going to go back. This is on my main desktop, so this is the other side of that trade. Transaction ID. Okay, so it took the other side of the trade and broadcasted the completed trade. If I go back to the Raspberry Pi, what happened there? It's still showing 2 trades, but every 5 minutes the garbage collector will go off, and I just saw it go off about a minute ago. This is part that needs improvement. I need to trigger the garbage collector right away after. But basically, so if somebody tried to take the other side of this trade right now, it wouldn't go through because the UTXO has already been spent, and so there's no danger in getting like someone accidentally taking it or anything. The transaction's final, and it's just waiting for the UI to update, so that's an improvement. But basically, in 4-ish minutes, the trade I just took will disappear from the list, and it'll disappear from everybody's list. That garbage collector goes through and checks all the orders and makes sure that all the UTXOs are unspent, and if they're spent, it deletes the order because it's no longer valid. So that's how I took the transaction. I'm going to also send this app, let's see, 6SCX. I have some USDH here. So this is a stable coin that's not used very much anymore. I'm going to send it one. I'll just send it. I'll send it 1 token. So this is essentially $1. It's a stable coin. And I'm going to put this up for sale on the Dex, and then I'll take it with my desktop computer. So yeah, here on my desktop computer, you can see that one of the one that got garbage collected. If I go back to, so I'm just going to check and see if I got the tokens. So I should have the 1 USDH. Oh, and there's the trout token that I bought. So see, I still have 0.99 PSF tokens. So that is basically how you take trades. That's pretty easy. You just browse and click buttons. But now what I want to do is list this USDH coin for sale, and then I'll take the other side of it with my desktop. So there's currently no user interface for this right now. What you do instead, so here I'm on the command line with the Raspberry Pi. There is, in the scripts folder, a create order script. And so I'm going to open that here on the command line with my text editor. And I'm going to edit this. This is set up right now for the trout token. This is what I use to generate the first order. What I need is, I need the token to be in the wallet, and I need the token ID. So for USDH, that starts with C4B. And I'm going to clear this line of the token ID. Okay, there's that. And number of tokens, I'm just going to sell half of a token. And I'm going to charge I don't know what, 100,000. You know, I don't know what the market price is for this right now. But I'm just going to say it's worth 100,000 Satoshis. That's probably more than what it's worth, but whatever, doesn't matter. Yeah, let's make it 10,000 Satoshis just for the sake, so we don't have any problems. So basically, those are the numbers you change. You change how many tokens you want to sell, and how many Satoshis that you want to sell them for per so this is per token, so rate and base unit, so it's 10,000 Satoshis per token, so it'll actually charge, it should charge 5,000 tokens. I've never done this with decimals before, so, and then minimum units to exchange, let's set that at 5,000. Kind of playing with fire here. Okay, and so now I'm going to run that create order. And I'm going to open this up in another terminal. So yeah, this is why we need a user interface for this part. Okay, I just want to watch and see what happens to the Dex once we get this script going. Create order. So there, I kicked it off, and there you can see it activated the REST API. And so what it's doing is it's going through the process of creating an order and then an offer. So an order is internal. An order and offer are basically the same thing. The difference is that an order is internal to the system and an offer is external to the system. Does not have enough tokens to satisfy sell offer. Okay. So let's I'm just going to restore that file. And I do have the one trout token. That's my desktop. I do have the one trout token, so I'm going to try and sell that back So in that case, I don't need to edit this the script. It's already got the token ID for the trout token. It's going to sell one token for 5,000 Satoshis. And so yeah, let's call that node create order. So it's doing the same sort of due diligence that it did on the last one, just verifying it. And if it passes the checks, then the Bch Dex makes a what I call a segregated UTXO. Oh, App Wallet does not have enough tokens to satisfy the sell order. Pretty sure it does. I will send it some more trout tokens just to make sure it does. So if I go send receive and go to my desktop, I'm going to send it 5 trout tokens. Sorry, this isn't so smooth. Like I said, this is a prototype, so there's going to be a lot of this back and forth. So yeah, A4F, that's what was in there. A4F, okay, so let's try this again and see if it goes through. Yeah, A4F. So there's the garbage collection going off again. I'm wondering if sending it the USDH screwed it up. But we'll find out here in a second. What I want to show is it putting the order into the pay-to-write database, and then that triggers a webhook to all the instances of the Bch Dex on the network that receive it as it becomes an offer at that point. So an order is internal to the system and an offer is external to the system. So all the instances of Bch Dex receive offers. Only this computer has the order that it manages, and then it's sitting there and waiting for someone to make a counteroffer and accept the other side of the trade. And this is why it's good to have it on a Raspberry Pi, because it must be going through because it's taken so long. Because the node needs to be online to listen for counter offers, and it's an automated process to check the transaction and make sure the other party isn't screwing you over. So it's not that it involves a human, but it does need to be online to react in a timely manner. If you shut it off, it'll check when you fire it up again, but it'll operate most reliably if it's online all the time. Okay, I'll let this go through and then I'll review once it comes up. Okay, that ended up being a bug, but it was actually a really good example of looking at the console logs of Bch Dex to see what's going on. And so I got the order to go through, and so I want to walk through that output. So here it's calling that post order call to create a new order, and here's the data it's passing in. So this is selling 1 token. Let's see, number of tokens 1 for 5,000 satoshis of token A4, which is the trout token. So what we're going to see here is it working its way through the workflow. So you'll see these different callouts in the code if you look at the code. So it's checking the UTXOs of the wallet to make sure that it has enough BCH and tokens to complete the trade. So it's got a BCH UTXO worth 66,000 satoshis. So that's enough to pay for everything. It's got 1 PSF token, so it'll pay for the pay-to-write database, and it's got 5 trout tokens, which is what we're selling 1 of them. So it meets all the criteria to create a trade. Generates a key pair to create a segregated UTXO, so it sets these tokens aside that it's getting ready to sell away from the main wallet, and generates a proof of burn, so it burns 0.01 PSF tokens to write to the database, submits that along with the data to the pay-to-write database, with the new, or this is an order model internal, and so it gets this CID or hash. It's an IPFS content ID back from the pay-to-write database, and that's how it tracks the order. And so after what happened, so now it's over and it returned, and it returned it returned this hash, this IPFS CID. And then a period of time went by, and the pay-to-write database churned on that data and verified it, validated it, and then after it validated it, broadcast out the information to all the other pay-to-write databases, and generated a webhook with the same data, and it converted the order to an offer. And this same event happened on every instance of the Bch Dex. So they're all receiving this data, including this one that generated it. And I should fix that. Anyways, it checks to make sure the offer is not already in the database, and then it creates a new offer. Checks the UTXO to make sure it exists, that it hasn't been spent, and then saves the offer information to the local Mongo database. And so if I go back to Ramina for the remote desktop, and I'm looking at the Raspberry Pi's UI, I can see that the order popped back up, this one token for 5,000 Satoshis. That's the order we just created. It's the one we took, and then it's the one that we just made. That's how you buy and sell tokens. So because this is going to be a rapidly evolving code base, including the dependencies like the pay-to-write database and the IPFS cord library that ties the whole mesh network together, this is a software stack to support these trades, as well as Bch Dex, the trading engine itself. These are all going to get worked on by the PSF over in the foreseeable future. And what's going to pay for all these updates is going to be the burning of those PSF tokens. And so expect to see frequent software updates. What I want to walk through next is how to apply a software update. So I'm here, I'm back on the Raspberry Pi. My Docker containers are running. And so I'm going to apply the software update, I'm going to go Docker compose down to bring them down. And see if I have any changes. I don't have any changes I need to worry about. And do git pull. Now right now there's no updates. Oh, I guess there were some updates there. Yeah. So this is a perfect example. I went git pull and pulled in some updates, and these are actually to the Docker compose. And if I go git log, I can actually see the code commits. So this is a fix to production, which is what I'm running, the Docker containers, to auto restart Bch Dex. So that sounds like a pretty handy update. I definitely want that. So, and I just pulled it in. And so now that that's in, let's just check the README to make sure I'm doing things correctly. Yeah, so I walked through everything that's in there. We did git pull. We brought the Docker containers down. We did git pull. It's generally a good idea to go npm install at this point. Yeah, I'll just do that. And this way, if anything in the package.json file changed, you'll just automatically install those updates. Okay, and then after doing that, run docker compose build no cache. So like I said before, the no cache option tells Docker to not. It forces it to not reuse the previous containers. It forces it to go out to GitHub and download the source code again, which it normally would not do. And so that's why you need that no cache flag. And this is going to take a while, but that's how you apply an update. After that completes, after you rebuild the Docker containers, there's a shell script called cleanup images, and what that'll do is it will delete the old Docker images. Those can build up and really take up a lot of disk space, so it's good to do this every once in a while. You don't have to do it every time, but if you're wondering where your disk space went, run this command. And then you can bring the Docker containers back up as I showed before with Docker Compose up -D, and then you're back off to the races. You don't have to do anything with the wallets. Everything's saved that way. The pay to write database should be good. Occasionally, you may need to delete that data folder. So there's production, and then there's the Docker, our PyDocker, and there's that data folder we created. Sometimes, especially if things aren't working right and you just can't, it's hard to debug, it's good to bring down the Docker containers and delete that data folder, and then bring the containers back up, let the pay to write database sync again, and that'll get you into a good state. All right, so please consider joining the Telegram channel or the Gitter. It's web based, so if you don't like Telegram for some reason, you can do that. That's the links for those are at the GitHub repository under this participate in the README. Hope to see you online.